Okay, to solve question 31, we're going to use our calculator and run a quadratic regression. Now, the reason we're going to use our calculator here, and we didn't on the previous question, is the previous questions gave us exactly 3 points. And a lot of times it said, determine whether a quadratic model exists, which means that it had to fit perfectly. Or it just said to write a quadratic model or find a quadratic model for the set of values, and it gave us, again, 3 points. So we can do that by hand. Now, when we're given more points, and it may not fit perfectly, but it fits very closely to that parabolic curve, we want to run a quadratic regression as we did a linear regression several chapters ago. So again, the first thing we need to do is we need to input our data, and the way that we do that, we go to Stat, and then Edit. List 1 is X, and List 2 is Y. Now, the question says, find a quadratic model for the data. Use 1974 as year 0. We're talking about postal rate. So 1974 was 0, as you see here in list 1. 1978 then would be 4. 1981 would be 7. 1983 would be 9. 1988 would be 14. 1995 would be 21. Let's see, 2001 would be 27. And we'll go all the way down here. And then 2002 would be 28. Okay, the corresponding Y values, postal rates, I guess the cost of the stamp, and cents. Okay, 1974, year 0 was 10, and 15, 18, 20, 25, 32, 34, and 37. Okay, make sure you have the same number of X's as you do Y's, or you'll get an error dimension mismatch. Okay, now that we have this in here, we want to run our quadratic regression. So we hit second quit, and we go to Stat, arrow over to Calc, and we want to run a quadratic regression, which is 5. Okay, and this is our equation. Now I know with linear regressions, we would just go to y equals bars, statistics, over to equation and copy the regression equation. Now unfortunately we can't do this with quadratic regressions, and I'm not exactly sure why. But there's another way to store it under y equals, so we can copy this down exactly as we see it. So we want to use this. The reason we want to copy it into y1 is we're going to use the table function to find some other values. In this case, when the first class postage was 29 cents. So what we want to do here is we want to go to Stat, Calculate, Quadrag, but we don't want to hit Enter. What we want to do is we want to select list 1, because we want to run the quadratic regression using list 1, is our X. List 2 is our Y, and you could switch that, the X's and the Y's, if you wanted to switch it for whatever reason. And what we want to do is we want to post this, go to vars, we want to paste this under the Y1 equation, or label under Y equals. So we want to select that. Now from here, when we hit enter, it's going to take this, and what you see is it pasted it under Y equals. Now when we go to second table, it says to predict or estimate when first class postage was 29 cents. Now it might have been beneficial to switch X and Y here, but again, Y, remember, was the cost of the stamps. So we want to see when that was 29, and how it does say estimate. So when it was 29 cents, we can come here and we can see that it was between 18 and 19 years. And that's from year 0, which was 1974. So 74 plus 18 is approximately 1992 or 1993. So that's how we got the answer for B. And then it says predict when first class postage will be 50 cents and explain why your prediction will not be valid. Well, because we use a quadratic model, there has to be a max. And the max value of the postage rates, according to the data that we had, would never reach 50. So that's why it's not going to be valid here. But this would, I guess we'd have to test, would be a better model than a linear model, a linear regression. And the reason I say that is if we come back here, I'll have to run this quadratic regression again. When we do this, what we see is this regression coefficient right here of r squared is very, very, very close to +1, which means this is a very, very close fit which means this data fits this curve very, very well. And that's why I would say that it would be better than a linear. Let's see, let's run that linear regression. Calculate linear regression. What we see is 0.993. Not the r squared, because this is x to the first, just r. We see it's very close to 1 as well, so it's very good. We might want to use that if we want to predict when the postage would be 50 cents. But because we're using a quadratic regression, the maximum value of the vertex of our function is actually less than 50, and so according to our model, we'll never get that high, which hopefully is the truth, but I doubt it. And that's how you solve question 31 using the graphing calculator.